right, so we were at what are databases used for? So the examples that we were using before, those examples like to store information about people, for instance, patients in a hospital or school, to store information about things like cars to be sold, books in the library, information about events like hotel bookings, results of races. All of these can have databases, and you can make a database out of anything that is storing a bunch of related data inside, right? So every single basically like database has either a field or a record. So a field is what you call a specific area in which you store data of like the data itself that you want to store it inside. The record is the considered the row, and the fields are considered the columns. All right.
Okay.
All right. So which consists of many records. Each record consists of several fields. We already talked about that. The number of records in a table will vary as the new records can be added and deleted. We discussed it before. Every database can have alterations depending on the people using it and the scenario it's used in. So the number of fields in the table is fixed. So each record contains the same number of fields. An easy way to remember this is that each record is a row in the table and each field is a column. You can see this in the diagram here. So while the databases can contain multiple tables, all the databases considered in this chapter will be containing a single table. Okay, so you don't have to worry about how a database can have multiple tables. They can, but in like O levels, you're just going to be studying what a single table can or can't do. So commonly, you can have a table of what? You can have a table for patients or called patient maybe, or books for book, and appointment for doctor appointments. All right, here. So each record within a table contains data about a single item. Let's say Winnie Singh, a hospital patient. So Winnie Singh might be like inside, let's say, record 2 and field 1, where the name is stored and the patient number is stored or things like that, right? So for a hospital patient, the fields could include the patient's first name, the family name field called family name, or the patient's date of admission field called date of admission. So you can have multiple information about a patient stored in a single record, right? So in the record one, let's have an example here. Yeah. So the patient table, for example, has the record one as all the column headings: first name, family name, date of admission, consultant, these things. And then in record 2 onwards, you're going to start talking about the actual name here. Let's say it was, what was the name that they used? Winnie Singh, for example. You can have Winnie here for first name, Singh as their family name, date of admission, and consultant, all these details stored inside that. Right.
Okay.
So the next thing you talk about in databases is validation. We've looked at validation inside programming. It's kind of similar to that. So some validation checks will be automatically provided by the database management software that is used to construct and maintain the database. Other validation checks need to be set up by the database developer. So some of them are understandable. Like for example, in first name, the validation check would be to see if the data stored is a string or not. If it's not a string, then that's an invalid type of data being entered. Like you can't enter a number inside a names field, right? So things like that would come into place here. But some are checks that the developer needs to put in. So maybe this kind of check could include something like the patient name doesn't actually exist or didn't actually come in, whereas we have that name stored in the database. Like that's one thing, right? The practical use of a database management system is strongly recommended for all students. All right, so this is talking about how it's better if you actually practice, like there are database management software or DBMS as you would call it, and some of them include things like Microsoft Access. There are other ones that like we used as well, but we can look at that a little. These are the practical examples of that. So, for example, the date of admission field will automatically be checked by the software to make sure that any data input is valid date before it can be stored. So, for example, here, data admission entered 99. This is automatically giving us a check of or an error saying that the value you entered isn't valid for this field. For example, you may have entered the text in a numeric field or a number that is larger. 99 doesn't like what is 99? You in the dates you have a specific format you need to follow, right? So here this table you see here is a general validation check that your database management software automatically does. So field size, for example, has a type of integer. And here, where is the validation rules of greater than equals to 1 and less than equals to 100. This is the word number validation rule here. They said this is the word number check for a validation rule. So they've told you what type it should be. They've said what rule or the range it should be in. Like they only have 10 words available, and the text that's shown are words number are 1 to 10. And these are all the things that like they could put on the screen based on the developer.
Okay.
So here, when someone enters ward number 67, there's an automatic message showing on the screen saying what ward number are 1 to 10. And then you have to like basically enter it again.
All right.
So the data types that you see here are basically the same as the ones you saw in pseudocode. So you have text or alphanumeric, which is what you would call string in pseudocode, characters or char, boolean, integer, real, date, time. So we already know what a data type is. It's something that is trying to store the type of the data itself, like the kind or the way it would be shown, like integers or would be values or numbers and things like that, right? So they're just talking about that again. Text alphanumeric is basically a number of characters, or you would call a string. It could be either short or long. Character is a single letter, number, symbol, anything that is just one space long. Short text with a field size of 1. Boolean, again, true or false, 1 or 0, yes or no. Integer is a whole number. Real is the decimal numbers, and date and time is a specific format of date or time. All right.
Oh, the data. All right.
Right. So, in every record or every single thing you see in a database, in a table, every every table has its own primary key. A primary key is something that is unique to everyone. So for example, you could say that a patient name might be repeated. Two people might be called Tom. It's possible, right? But that same person, those two people cannot have the same patient ID. That's how you differentiate between the two of them.
All right.
Right, so that would be considered your primary key in that specific scenario. So as each record within a table contains data about a single item, person, or event, it is important to be able to uniquely identify this item. In order to reliably identify an item from the data stored about it in a record, there needs to be a field that uniquely identifies the item. This field is called the primary key. So primary key must contain data values that are never repeated. It has to be unique for every single record that exists. The primary key can be a field that is already used, provided it is unique. For example, the ISBN in the book table. The patient table would need an extra field, so you would have like a patient ID for that. And yeah, all right. Primary key field called hospital number. That's possible as well. For maybe this is a database of all the hospitals that exist, and so you need a specific hospital number for every single record.
Yeah.
All right. Okay. Let's try this one. This activity 9.4. Write down 4 database types. Database data types. Describe each data type and give an example of a field where it would be a suitable choice.
A single database contains only one. Wait, I was right on the first one, right?
A single, could you repeat that?
A single database.
Yeah.
Contains only one. Wait. A single database contains only one. Wait. Kind of. Data type.
A single database contains only one. No, because a database has many records and things, right? It can have many data types.
Oh, so then there will be only one table, maybe?
Yeah, a single database contains only one table.
Each consists of many dash. Each, each record
Mm-hmm.
consists of many. Okay, this is each record consists
Confusing,
of.
yeah. Let's look at this one together, but we might have to move things up and down. But each
We
dash
can't
consists of
just say
many. Sorry?
we can't just say each record consists of many records.
Well, no, but you could say each table consists of many records, right?
Yeah, you could also do that.
Yeah, and every dash has the same number of dash. Every dash is given a dash, and examples types are okay. That one's easy. Some dash will have rules. So that is the last one's easy as well. So you can like start cutting down by the ones that you do know. So for example, some dash will have dash rules. What could this be?
Um, some dash will have dash rules. Some wait. Some fields
Mm-hmm.
will have um
What are rules that we can apply things on?
like rules that can be true.
Rules that can be true. Like yeah, I mean, why would we want to apply rules on any field?
Will have um I mean Boolean can't be it, right?
No, Boolean is a data type.
Yeah,
Well, fields will have validation rules because that's what we need to validate on certain rules, right?
yeah. Wait.
Right? Okay.
Okay.
All right. And examples of data types are this one's easy. This one's they have it here, right? Char, Boolean, and there should be one more. Text.
Text.
Okay. And then let's a single we can do this one. A single database contains one table. Each we'll do this one at the end. Let's see this. Every dash is given a dash. So let's say every record is given a data type.
Every
Let's let's
record is a data type.
let's compare this one. Oh, sorry, not every record. It should be every field is given a data type. But let's compare this
Yeah,
one.
every field.
Um, it's a this one is just a record. So every field must have the same data type or have a data type. Where to go? This one. Every field. Oh, sorry. This one's fields. They have that separate as well. So every field is given a data type. Every dash has the same number of dash. So this one would be every record has the same number of fields, right?
Every record
Because we have
has
look
the
at look
same.
at the table here actually.
But we used
Um,
fields.
so we know we had two. We had fields and field, and we have records and record. Look at this.
Oh, I got it.
We got field here already, and we had fields as well. So every record has the same number of fields, right? So like all these records have the same number of columns. All the rows have the same number of columns.
Yeah.
Yeah. All right. So the last one, this is where we were getting things messed up. So here, each dash consists of many dash. This would be, what do we have left? We only have two left. Wait. Sorry, you can use some words more than once. Okay. So a single database. We done database? Yeah, we have. A single database contains one table, or yeah,
It could be something.
each yeah, I think this could be something else right now as well. Each dash consists of many dash. So we've already done this one as well. We have done all of them except for the first one.
But which one was Boolean?
Boolean was here. Examples of data types are char, Boolean, and text.
Oh, okay.
Right.
So you're
So
left with records and primary key.
it's not necessary that you use those at all, but since they said you can use some words more than once, but each dash consists of many dash. Like each something that one, it's like a one-to-many relationship, right? So a single
Yeah.
thing that has many others. This, I believe 100% this would be record to fields. Yeah. A single this could also be a single database contains one primary key, but that's not necessarily true. You'll study this in like later A-level
Wait,
stuff.
teacher, you're lagging.
Uh, is it fine now? Is it fine now?
Hello?
Can you hear me?
Can you hear me? Are you there?
I can hear you, but something weird with my Wi-Fi. Can you hear me? Hi, can you hear me now? Hello?
Yeah, I can
Hello?
hear you now.
All right, great.
Can you
So,
hear me?
yes, I can. I think, yeah, okay.
Hello, can you hear me?
I can hear you. Can you hear me? One second. All right, can you hear me now?
Yes, I can hear you now.
All right, so, where were we? This part, each dash consists of many dash. So this is each record consists of many fields, right? A single dash contains one dash. What do you think this could be?
A single primary key? Wait, no, I cannot use that though. Oh, a single database
Yeah,
contains one table or
one
record.
table. Yeah, exactly. This one here, every dash is given a dash. We can change this as every table is given a primary key as well. We can have this as well.
Yeah.
All right. So the next thing we're going to look at is the SQL, structured query language. This is basically a kind of language that we use for databases, specifically for altering databases or making databases. It's the developer tool. So we will be using SQL to obtain information from single table databases. This will provide a basic understanding of how to obtain and display only the information required from a database. So SQL is you have like SQL scripts that you write down to basically code this in. And they have certain keywords, like you know how there's pseudocode, there's SQL as well. So here, the first keyword you have is select, which basically fetches specified columns or fields from a table, and queries always begin with select. So select basically it displays a certain column. So you would write something like select select like a certain column name from a certain table, and it ends with the semicolon. So here, for example, select field 1, field 2, field 3, and so on, and from a certain table. Why don't they have it all written here? From table name. Do you understand the first one?
Yeah, select.
Yeah. And then select, basically you're going to select a certain field name from this from here, identifies a table to use. So from a table name. And if you want to specify which like which names or which field names you want or field specifications you want, you're going to write where. Where includes only the records or rows in a query that match a given condition. You can also order it in ascending or descending order. This sum is basically to add them up, so it returns the sum of all values used with select. So select from where, or select from sum and stuff like that. So count counts the number of records where the field column matches a specified condition used with select. So these things are used all like after select. I'll show you an example and you'll get what that means. So here only the select and from commands are mandatory. So in out of all of these, it's necessary to use select and from. These others depend on your question. So you need to select you need to use select to specify which fields you want, and from is used to basically tell you which table you want it from. And if you want all the fields, for example, you want every single field to be displayed, you're gonna use an asterisk sign like this.
Oh, okay.
Okay. So here, from table name, this specifies the table to use. Where condition specifies the condition to apply. So conditions often include values from fields. These values need to be stated in a form that matches the data type for the field. So for example, if you have a text, the example value might be Mr. Smith. Text field value should be in an enclosed single quotation marks. Double quotation marks can also be. So this is like the same as a string, the way you would store data. Character, again, is the same as that, a single character. Boolean true, integer is like a whole number. Real as a decimal number. Date time has a specific format. So you'd have day, and then the month, and then the year. Okay?
All right.
And these are the same programming operators that we'd use, like equal to, greater than, less than, greater than, equals to, until here it's the same. After this you have between, like, in, and, or not. In and or not was there as well before, but between, like, and in are new, right? So between means between a range of two values. Like you might say something like select field 1 from table 1 between like 1 and 10, for example, depending on your condition.
Okay.
Like is to search for a pattern. So you'd have a specific format that you write down. So maybe I have a text where I have like a name called a name field. Okay, so I'd say something like select first name from patient table. Like in quotation I'd write Mr. and then after that whatever comes forward, which you'd represent with a percentage sign. I'll explain what that means a little later. But this like is basically going to help me find all the names that start with Mr. in my records. Okay.
Okay.
Okay, and then you have the order by statement. Order by field 1 or field 2. So this is just going to place field 1 in ascending or alphabetical order, starting with the first field. All right. So field 1 will be considered here, and then field 2 will be the next ordered one, and so on. So order by field 1, field 2 descending would mean, or like automatically when you have nothing written next to it, is going to do ascending. If you write down DESC, like for the short form of descending, then it's going to order the fields by descending order.
Oh,
All right. Sum statement. This is to take the form of a sum. So select sum field. So this would just add up all the values inside a specific field and display the output for that.
okay.
Similarly, like sum, you have count to count the number of fields you have existing. So select count, and then in bracket, you're going to write down the field name. Right now, the way you're going to properly understand these is by some kind of example. So let's look at this one. It says you have a single table database for patient would provide a list of all Mr. Smith's patients showing the hospital number, first name, and family name. So they told you in the question to provide a list of all the Mr. Smith's patients that these are the Mr. Smith patient is like all the patients inside the list, but the hospital number is what you want the field name. The first name is what you want as another field name, and the family name. So these are already some fields that you have. And so first you're going to write select the hospital number, first name, and comma the family name from the patient table, where, because they told you that you want only the Mr. Smith patients, right? So where the consultant is equals to Mr. Smith. So this would give you the output, like the hospital number column, the column would be shown, the first name column would be shown, family name column would be shown, and only these two rows are shown because these two are the only ones that have Mr. Smith as the consultant.
Right.
Do you have any doubt in this?
No.
All right. So similarly, we have another example of sorting the alphabetical order of family names. So let's say you want to sort this exact same question, but in ascending order. So you're going to have, again, select hospital number, first name, family name from patient, where consultant is Mr. Smith, order by family name. So this is automatically giving you ascending order.
Okay.
All right. All right, so let's look at this one. Using the single table database patient you have created, write an SQL query to list all Mr. Jones patients. So you need to list down all of them. And how would we do that? They didn't tell you any column names. So this means that you want to list down all of the details. So the way you're going to write this is select asterisk from patient where, what was this condition? Consultant is equals to Mr. Jones.
Mr. Smith
Yeah,
or
and then the
Jones.
semicolon.
Okay.
Similarly, write an SQL query to list all the patients not in Ward 6, not in Ward 6. So everyone other than those that are in Ward 6. Here we would do select asterisk again, select asterisk where from patient where patients like the ward number. What was the column name that they used for this? Here, yeah, here, ward number. This is the column like name or the field name that they're using. So here, not where the ward number is not equals to 6 and semicolon. Write an SQL query to list all patients who arrived on 12/11/2022. Here you would do what? You would write down again, select asterisk from patients or patient table, where the date or the admission date is equals to 12/11/2022. Here they have the and, like they said that you want both, right? So here you would say, again, it would start off the same way, but in the where condition, you would write where admission date is equals to 12/11/2022, or sorry, just 12/10/2022, and the admission date is equals to 30/10/2022.
Okay. Yeah, this date part is easy.
Yeah, exactly. Now, here they gave you the code itself and they're asking you for the output. So what would be the output of this?
It's gonna be basically if you scroll up.
One second. Let me take a screenshot of this thing, and then we'll compare that. All right. Hello?
Yeah. So it like says where ward number equal to 7.
Yeah.
But like in ward number, there's like record is only like 6.
Where is 6? This is we don't have the database. We're just assuming. Let's just assume random, data entered in this. It doesn't have to be 6. This is another question.
Oh, okay. So how are we gonna like write it?
I mean, they gave us a code. We don't have to write the code. We just need to tell them the output. So the output is something like you know how we saw these here. One second. These here, you would have again the question. Even the question has hospital number, first name. Sorry, not this one. First name, family name, and bed number, right? So as you have hospital, like as you have see this output here, you're gonna write down family name and over the other two. Family name, first name, family name, and bed number in this order. And then these would be only displaying the data of those where ward number is equal, or the patients that have ward number equal to 7.
Yeah.
All right.
All right.
Okay. All right. Let's go to see some actual examples. All right. This is practical. I'm not sure if your teacher is gonna make you do this, but could you ask them to confirm if this chapter is like if they're gonna